Hi. Welcome to the session on creating and managing tables. In this module you will learn about various data types in Oracle, how to create a new table, how to alter an existing table, how to drop and truncate table, finally about various constraints. Data definition language defines the structure of database of objects. There are 4 different types of statement. Create, to create new database objects. Alter, to modify an existing structure of the DB objects. Truncate, to remove all data from DB objects. Drop, to remove the DB objects from database. We will be using insurance management system throughout this module. There are 3 tables used in IMS. First, a customer table will store the information of each customer. Second, a policy table will store the information about each policy plan available in the insurance. Third, policy enrollment table will store the information about the policy taken by a customer. Here are listed sample records available in customer, policy and policy enrollment tables. Data type represents the type of data which can be stored. Where char2 is used to store variable length character data, wherein char is used to store fixed length character data. Number data type is used to store both integer and float value. Date is used to store date and time value. Here is a syntax for creating a table and an example for the same. To name an identifier, the following rules are to be followed. Only letters, numbers and underscores are allowed in names, but we should start the name of the identifier with a letter. Always provides a meaningful table name. Here are a few examples for valid and invalid names of identifiers. If you have a look at the records inserted, 2 members have the same member ID. It will create a problem when you want to identify the record uniquely. How can we resolve this? We can restrict it by having a constraint. Constraints are the rules enforced on data columns on the table. These are used to limit the type of data that can go into a table. This ensures the accuracy and reliability of the data in the database. The various type of constraints are primary key, foreign key, unique, not null and check. A table can have 1 primary key, but it can have a number of foreign keys, unique, not null and check constraints. 2 columns joined together can be made as a single primary key. Each table in a database should have a primary key. An attribute, sometime attributes, which defined as primary key, must be unique and must hold a value to identify the record. Here, we can make CID as the primary key, so that it does not allow any duplicate value and null value. If we don't want an email ID to be duplicated, can we mark an email ID as the primary key? No. Some customers may not have an email ID, but we can mark it as unique, so that no duplicates are allowed, but null values are allowed. Can we mark name as unique? No. Some customers might have the same name. We can mark it as not null, so that the null values are not allowed, but duplicate values are allowed. How can we ensure whether the user is providing a positive value for the amount to be paid? We can make use of check constraint to do this task. Check constraint enables a condition to check the value being entered. For customer table, CID is a primary key. For policy table, PID is a primary key. For policy enrollment table, enrollment ID is a primary key. But, in policy enrollment table, there is an entry for CID as 3, but there is no customer with the ID 3, then how can there be an entry in the enrollment table? This problem can be resolved using a foreign key. Foreign key is used to enforce the link between the tables. The reference table is called the parent table, while the table with the foreign key is called the child table. The primary or unique column of the parent table can be created as a foreign key column in the child table. In enrollment table, we can mark CID and PID as foreign keys to ensure integrity. Attribute CID of a customer table and attribute PID of a policy table is used as a foreign key of a policy enrollment table. Here, customer and policy tables are called parent tables, while the policy enrollment table is called child table. Here are examples: how to apply various constraints to attributes when creating a table. Customer table is a parent table and policy enrollment is a child table. On creating a table with a constraint, Oracle provides default name to it. The constraint names are stored in the built-in table called user_constraints. User can override the default constraint name with the user-defined constraint name. The example describes how to give a name to the constraints. Oh no! When we created a table policy enrollment, we forgot to give policy ID as the foreign key in the policy enrollment table while creating the table. How can we do it now? We can use the alter command to add the foreign key. Alter command is used to change the structure of the table. Alter statement used to do the following: add a new column or constraint, remove an existing column or constraint, rename the existing column, increase or decrease the column size, and change the column data type. Here are few examples of how to add a new column, increase the size of the column and rename the column. Here are listed few syntax of alter statement for various uses. How to check whether the paid date is greater than the due date in the policy enrollment table. Use check constraint at table level. Constraints can be column level or table level. Column level constraints are applied only to one column, whereas table level constraints are applied to the whole table. Truncate command removes all the rows from the table. You cannot truncate the table if it is linked with another table. After the truncate performance, a table is like a glass without water. Drop statement will remove an entire table structure from a database. In truncate only the data is removed, whereas, in drop, the entire structure is removed. In this module you have learnt about various data types in Oracle, how to create a new table, how to alter an existing table, how to drop and truncate table, finally about various constraints. Thank you.